Assalamualaikum warahmatullahi taala wabarakatuh. Today I would like to present the project of computer architecture lab, which is we from group 7. My name is Muhammad Khairul Anam bin Muhammad Ali, TG20047. Okay, for the abstract, Central Processing Unit, which is CPU, consists of the following features. Brain of the computer. Number 2, CPU perform all type of data processing operation. It store data, intermediate result, and instruction, which is program. It controls the operation of all part of the computer. For the introduction, the central part of a computer that executes command and does computations is called a CPU, or Central Processing Unit. It is referred to the computer's brain. The CPU carries out the following significant tasks, which is fetching, decoding, execution, and memory access. For the project background, first, von Neumann architecture, 1940s, introducing the concept of storing program, instructions, and data in the same memory, as well as the sequential execution of instruction. The second one, transistor and integrated circuit, 1915. CPUs transition from using vacuum tubes to transistor and eventually to integrated circuit, which allow for higher computational power and reduced size. Next, Moore's Law, 1965. Gordon Moore, co-founder in Intel, driving force behind the continuous improvement and miniaturization of CPU. Net microprocessor, 1970s. The development of microprocessor revolutionized the CPU's landscape. Okay, for the objectives of this project, to design a 4-bit CPU by using logisim that can perform tasks of a CPU, fetching instructions, decoding them, and performing the indicated sequence of operations. Instruction execution means the CPU fetches instructions from memory, decodes them, and executes them in a sequential manner. And the meaning of data processing, the CPU processes data by performing various arithmetic and logical operations, which is ALU. Next, control unit management. The CPU's control unit management the flow of instruction and data within the CPU. For the data storage and retrieval, the CPU utilizes register to store and retrieve data during instruction execution. Next, communication with other components. The CPU acts as a bridge between various hardware components in a computer system. Okay, theory of this project. Von Neumann architecture. This theory describes the structure of a digital computer, including the CPU, memory, input-output device, and bus system. The von Neumann architecture is a sequential architecture, which means that instructions are executed one at a time. Instruction set architecture, which is ISA. This theory defines the instruction that a CPU can execute. The ISA specifies the format of instruction, the addressing mode that can be used, and the supported operation. Pipelining. This theory divides instruction execute into stages, enabling simultaneous execution of instruction and increased throughput. Pipelining is a key technique for improving the performance of CPU. Next, cache and memory hierarchy. This theory uses different cache levels to store frequently accessed data, reducing the need for slower main memory access. Cache are small, high-speed memory units that store copies of data from main memory. Okay, now we go to the methodology. 15-bit ALU, which is 15-bit arithmetic logic unit. Okay, here, a 15-bit function ALU is a digital circuit that can perform arithmetic and logical operations on binary numbers that are 15-bit long. Int is a key component of the CPU or central processing unit, which is the brain of a computer. The CPU uses the arithmetic logic unit to execute instructions, which are the commands that tell the computer what to do. Okay, here I would like to explain about the function of arithmetic logic unit 15-bit. Okay, for example, this is A and B. A is input 1, B for input 2. Okay, for the example, we put the 10 for A and B 10 also, which is in decimal, this is number 2. Okay, for adder, we must set the function select to 100. 2 plus 2 equal to 4, which is 100 in binary number. For the subtract, we must set the function select to 101, which is when A minus B equal to 0. For the multiplication, we must set the function select to 110, which is 2 multiplied by 2 equal to 100. 2 multiplied 2, which is 4, and 4 in binary is 100. Okay, for the function of divide, we must set the function select to 111, which is 2 divided by 2 equal to 1.
Assalamualaikum warahmatullahi wabarakatuh. My name is Syamil Afif bin Kamal Zaman. My matrix number is TG20043. As we can see, this is the 4-bit data path. The 4-bit data path refers to the part of processors that performs the arithmetic and logical operations on data. It consists of various components such as registers, arithmetic logic units or ALU, multiplexers, and databases, which work together to execute instructions and manipulate data. The primary function of the data path is to carry out data processing operations required by the instructions being executed. It enables the CPU to fetch the data from memory, perform arithmetic or logical operation on the data, and store the results back into memory or registers. Then, this is the 4-bit register file. The 4-bit data path is the control unit coordinates the operations of the components such as registers, ALU, and databases. It controls the flow of data and signals between these components, directing the movement of data during the instruction execution. And after that, This is the 4-bit control unit. The 4-bit control unit plays the crucial role in coordinating or controlling the operations of various components within the CPU. It generates control signals based on the instruction being executed and ensures the appropriate actions are taken at each stage of the instructions. And finally, this is the central processing unit, or we call CPU. A 4-bit CPU is a simplified form of the central processing unit that can only process 4-bit data. This means that each instruction or data word is made up of 4 bits or binary digits. 4-bit CPU are typically used in educational or early computing systems because they are relatively simple and inexpensive to build. As we can see here, we are using the data path and the control unit that we made before. For the discussion, the 4-bit CPU are straightforward, low-cost processors with a limited data processing capacity. They are excellent for education, applications, and low-power gadgets, but they are less potent than other kinds of CPUs. The advantage of 4-bit CPU is they are simple and inexpensive to build, and they consume less power than other types of CPU, and they are easy to learn and use. For the disadvantages of 4-bit CPU, they can only process small amount of data, and they are not as powerful as the other type of CPU. What the result is, this is the full build of the 4-bit CPU. As we can see with the instruction, reset, start, and clock as the input, and we have data path and control unit, and we got ROM and the ready and RAM for the output. But unfortunately, the result applied is not correct, and we didn't manage to find the error. And we are also trying to fix the circuit as soon as possible. Finally, the conclusion is 4-bit CPUs are simple, affordable, and low power. They are good for educational purposes, low power devices, and applications with simple computational requirements. However, they cannot handle large amounts of data or perform complex tasks. Despite this, 4-bit CPUs are valuable learning tools and viable options for basic control systems and embedded applications. And for the reference, there are 2 websites that we use to find information about the CPUs and use to complete the circuit and the task given. So that's all from me and my teammate Hera Anam from Group 7 for the group project of the Computer Architecture Laboratory. And we are sorry for our lateness, and we always try to improve and give our best for the future. That's all. Thank you. Assalamualaikum.